Okay, the goal on this is to find the equation of the function that's going to give the graph where we take the graph of 1/4 raised to the x power, but it's been reflected about the x-axis. And after we find that, we'll find the domain, range, and horizontal asymptote. So it's important to note that, first of all, the x-axis, the horizontal line going across here, this is going to be reflected about it. So what that means is everything that was up above the x-axis, all these points are going to get transferred below the x-axis. So our graph gets flipped upside down. So hopefully that looks like a nice facsimile of what's going on. Not perfect as far as my drawing goes, but the whole thing's been flipped upside down. Everything that was up above gets transferred down below. So all these points shift below the x-axis. All right, so this is a vertical movement. That's important to note. So it's going to be a reflection which always incorporates a negative. So what we want to do is say, well, if everything's been moved vertically, we need to attach a negative to the entire function. So not up here with the x and the exponent. Instead, what we're going to do is include a negative attached to the entire function. And I guess they told us to call this g of x. And that's the equation of this function that we're looking for. All right, it displaces all of these y values and switches them into negative y values, basically. All right, so here's our basic sketch of our graph. The domain is still going to be negative infinity to positive infinity. We're allowed to plug in any x value we want into any of these exponential functions. Now our horizontal asymptote is still at the x-axis. Over at the right-hand side, originally we got close from above the x-axis. Now we're still going to get close to the x-axis, but from below. So we can state that our horizontal asymptote is still going to be at y equals 0 at the x-axis. Our range has changed as well. You'll notice over on the left-hand side, we go down to negative infinity, which never gets included. And then we get as high up as we're going to get very, very close to the x-axis, or our y value of 0. So we're going to say that's 0, but we're not going to include it, meaning that we get infinitely close, but never quite get there. All right, one more of these transformation problems. Let's find the graph of the equation for a function g of x that reflects f of x, which is 1.25 raised to the x power, which I've kind of sketched in here. But this has been reflected about the y-axis. So in this case, we want to remember the y-axis is the vertical axis. If we reflect things about the y-axis, that means that all the points on the right side go to the left side. All the points on the left side are going to transfer over to the right-hand side. So a rough sketch of what this is going to look like, it's going to be something along these lines. So we have 1.25 and then raised to the x power. Whenever we have a reflection, it's always going to be indicated by some sort of negative being attached in here. Now we just have to be careful of this one moved left and right. As far as the reflection goes, it got reflected about the y-axis. So whenever we have a left or right shift or movement or transformation, we're going to attach a number directly to the x. So in this case, so it's a reflection, so that's going to be indicated with a negative. We're going to attach a negative directly to the x. And I guess we'll call this one g of x, because that's what we were given as a function name. So the red graph is g of x, which is our reflection about the y-axis. Now, as far as identifying the domain, is still going to be negative to positive infinity, as it is with all of these exponential functions. Our horizontal asymptote is still going to be at the x-axis. But instead of getting close to it at the left-hand side, our graph is going to get close to the x-axis on the right-hand side. So we're going to use y equals 0 to indicate the x-axis. And then finally, our range. The entire graph is above the x-axis, gets very close to it. So I'm going to use 0 to infinity. If we track this graph over to the left-hand side, it goes up forever. So that's when y equals positive infinity. All right, hope this helps out in building up a function that's doing the right thing as far as what they ask us to do with reflections, and then identifying domain, range, and horizontal asymptote. Good luck.